I'll be talking about what binomial what expansion. What's a binomial? A binomial is a pair of a number, let's say a plus what b raised to what a particular power. And this sign connecting them can only be what either plus or what minus. So whenever two numbers are connected by what plus or minus and they have what common power, that's what they call what binomial. And this binomial can be evaluated from what two perspectives. Either you use what Pascal triangle or use what the combination. Now, a Pascal triangle is simpler, but it has its own what deficiency. Number one, it can only give you what the coefficient, but it cannot tell you about the power. And neither can you actually use it what to expand or to predict a particular term in any what expansion that is quite what large. For instance, if you are given a case of what, let's say x plus what y raised to power what 40, and the question only demands that you find what the 37th term. For you to expand all of them just to get the 37 times, you all know that it is time what consuming. So that's why the combination of methods comes into play. Now, just a little bit of what refreshing your memory, I will illustrate what the Pascal triangle is all about before I move to the combination method. Now, if you are given, let's say, x plus what y raised to power 1, an expansion of this, I'll still have the same thing. So the coefficient of x here is what 1. The coefficient of y is what 1. If I have x plus what y raised to power 2, expansion of this, I have x squared plus what 2xy plus what y squared. Pick out the coefficient. I have 1, 2, 1. That's 1, 2, 1. Now, if I have a case of what, let's say x raised to power 3, without expanding it, all you have to get a subsequent term is what? Repeat the one that is there. This plus this, you have what? 3. Then this plus you have 3. Then drop this one down. If it's power 4, this have to get out of 4. Drop the 1 again. Then add this to this, I have what? 4. Add this to this, I have 6. Add this to this, I have what? 4. Then drop the 1 that is there. If it's power 5, repeat the same thing again. I have drop the 1. This is 5. This is what 10. This is what 10 again. This is what 5, and this is what 1. So that's how to get the coefficient of what any particular expansion. Now I'm going to apply to expand a particular binomial. So you see how it works. Though it's not the main focus for today. Now, let's say I have a case of what? Then I have a plus what? B raised to power what? 3. Just here. That's the coefficient of what? Power 3. Now, if I want to expand that, the trick is that what? This first term, the power will start from what? 3 and move to what? 0. That's for the A. Then for the B, each power will start from what? 0 and move to what? 3. That will compensate for the what? The powers. Now, let us try that. Now, I have 1. A raised to power 3, b raised to power 0. Then I'll move to what 3. I have 3. A raised to power what? 2. That's 2, 3, 2. Then I have b raised to power what? 1, 0, 1. Then I have another 3 there. Then a raised to power what? 1, b raised to power 2. Then the last number there is what? 1. Then I'm going to have what? 1. A raised to power 0, b raised to power 3. Now, if you observe the powers, you notice that what? This is 3 for A, 2, 1, and 0. That's from 3 to 0. Observe that of B, 0, 1, 2, 3. Moves from 0 to 3. And these numbers are the coefficients that I picked there. On any case, if you want to know whether you're wrong, each time you add the powers, it must give you 3 because I'm expanding based on what power 3. If you were to the power 4, anytime I add a power, I must get 4. Addition of this is 3, addition of this is 3, addition of this is what? 3. So that is how to use that Pascal triangle, and which I will subsequently use again to illustrate something. Now let's look at the combination method, which is more useful instrument to use here. Now, if you were given a case of what, let's say a plus what b raised to power n, the possible expansion of that using the combination is what? N combination what? R. Okay, combination what? 0. Start from power 0. Then I have what? A raised to power what? N minus what? 0. Plus what? B raised to power 0. That will give the first term. Then I have what? N combination what? 1. A raised to power what? N minus 1. B raised to power 0. That will give the second term. Then I have N combination what? 2. A raised to power what? N minus 2. B raised to power 2. Now you continue that way. I have N combination R. A raised to power N minus R. B raised to power R, and the list goes on. That's the general form. So that is, I know it looks cumbersome or quite big, but just be a little bit patient. This is the first time if I'm to expand it, the second and the third and the fourth or fifth. So using a combination gives you both the coefficients and the powers of the what? The expansion. Let us take a look again. If we are to use this one to expand the previous example, which I wrote as what? Let's say x plus what? Y raised to power what? 3. And I want to expand that. So what will I do? I write 3. Combination 0. I have x raised to power 3 minus 0. Y, I'll have what? Raised to power 0. I'll move to the other one. Then I have 3. Combination 1. Then x raised to power 3 minus 1. Y raised to power 1. Plus what? 3. Combination 2. X raised to power what? 3 minus 2. Y raised to power what? 2. Plus what? 3. Combination 3. I have x raised to power what? 3 minus 3. Y raised to power what? 3. To simplify further, anything raised to power 0 is 1. I believe 3 raised to power 3 will be what? That's 3 minus 3 is what? 0. That will equally go there. So what will I have? I have 3 combination 0. X raised to power 3 plus what? 3 combination 1. X raised to power 2. Y 1 plus what? 3 combination 2. X raised to power 1. I have y 2. Then I have 3 combination 3. Y raised to power 3. Now simplifying that, 3 combination 3 is what? 1. I have x raised to power 3. 3 combination what? 1 is what? Is 3. I have x raised to power 2, y 1. 3 combination 2 is something as what? 1. 3 as well, sorry. I have 3, x1, y2, plus what? 3 combination 3 will give me what? 1. I have y raised to power 3. So if you take your time to actually what? Expand that, you will notice that it is the same thing as what? When I use what? Pascal triangle. But let us try to what? Apply this one more than the previous one. Let's take a good look at this example now. If you were given something of this nature, you were given x raised plus y raised to power what? 22. And the question says, find the 11th term only. Only the 11th term. Don't expand. 11th term only. Now, how do you solve such question? You don't have to expand it. Just only the 11th term is what you need. So, the general formula is supposed to use what? N combination r, a raised to power what? N minus r, b raised to power what? R. Our n is what? 22. Our r is still on, I'm still coming. A is the what? X. The b is what? The y. All we have to find is the what? The r first. Then when we find out, we can solve it. So how do we find the r? Remember, they say we should find what? The 11th term. So all you have to do is to write what? R plus 1 is equals to the 11. Just adopt that trick for now. To get the value of r, always do that. Always, if they say find the 12th term, you say r plus 1 equals to 12. Find the 20th term, r plus 1 equals to 20th. I will explain in the next video. Move this one over, I have r is equals to what? 11 minus 1. R is equals to what? 10. We found it. Now to get the value of the 11th term, so what do I have to do? I will have 22 combination what? 10. I will have x raised to power what? 22 minus what? 10. Then I have what? Y raised to power what? 10. So if I'm to simplify that further, I will have 22 combination 10. I will have x raised to power what? 12 with what? Y raised to power what? 10. So this is the value for the what? The 11th term. But if this were to be what? Negative. All you have to do, you come back to this formula, you put minus 1 raised to the power of what? R. That will compensate for the negative. Now, for all those ones that I've been solving before, let's say the one I solved for what? X plus what? Y raised to power what? 3. If we were to be negative, the sign alternates. What do I mean? It moves from what? Plus, minus, and plus. Let me give you an example again. Let me expand that again. So let's say I want to find the expansion of what? X minus y raised to power 3. So I'm going to have what? 3 combination 0, x raised to power 3 minus 0, y raised to power 0. Remember the first one is plus. So the second one is what? Minus. That's to compensate for this. Plus, minus, plus, minus. So I'm going to have what? 3 combination what? 1, x raised to power what? 3 minus 1, y raised to power what? 1 plus 3 combination 2, x raised to power what? 3 minus 2, y raised to power what? 2, minus now 3 combination 3, x raised to power 3 minus 3, y raised to power 3. So just notice the way it's alternating. Plus, minus, and minus. So that's just the difference between them. Now let's take a look at other examples. That will throw more light on the topic. Now, let us assume that we have something of this nature. Find the first sixth term of the expansion 1 minus 2x raised to power 8 in ascending order. So if I'm to do that, using the combination method, I'm going to have okay, just to explain more, my a here is 1, and my b will be minus 2x, and my n is 8. So our arrow is going to range from 0, 1, 2, 3, 0, 1, 2, 3, and 4, and 5. That's 1, 2, 3, 4, 5. So when you count it, 1, 2, 3, 4, 5, 6, those are the first 6 steps. So if you start from 0, it's going to end at 5. So mind you, don't start from 1. So if I'm to write, I'm going to have n combination r, a raised to power n minus r, with the b raised to power r. That's what I'll be using. So using that to write in this manner, so I'm going to have n combination r. I will have a raised to power 8 minus, n combination 0, a raised to power okay, let me use the values directly without wasting much of your time. So I'll just use it that way. So for the first one there, I will have 8 combination 0, our a is 1. So let me just put the 1. 1 raised to power 8 minus 0. I will have minus 2x, then raised to power 0, plus. Then I move again, 8 combination 1. 1 raised to power 8 minus 1. Then I have minus 2x raised to power 1 plus 8. Okay, that's plus. Here should be okay, since I've already accounted for it here, so there's no need. Then I have 8 combination 2. I'll have 1 raised to power 8 minus 2. Then I have 2, minus 2x raised to power 2. Then I will have a case of 8 combination 3. Then I have 1 raised to power 8 minus 3. Then I have minus 2x raised to power 3 plus 8 combination 4. I have 1 raised to power 8 minus 4. I have minus 2x raised to power 4. Then the last one there, which is 8 combination 5. I have 1 raised to power 8 minus 4 is 4. Then I have minus 2x raised to power okay, that should be 5. It should be 3 here. Then I will have this raised to power 5 as what I'm supposed to have. Now, looking at it now, why I did not put this plus, 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 and plus, all of them plus? Why? Because this negative here has already been accounted for. I use it that way, but in case you just want to write only 2x, that means that's when you start putting plus, minus to alternate it. So note that. So if I just remove this thing here, I have to start alternating it. But if I don't, if I pick it that way, there is no need again. So all you have to do is to use your calculator and punch these values, because they're a little bit bulky. I may not actually have the time to punch all of them. So on your calculator, you have 8 combination 0. It comes out 1 raised to power 8 minus 0 is the same 1. So you just punch in everything here and you get the answer. So let us take a look at another example. Okay, let's say we want to find find the coefficient of x raised to power 5 in 2x minus 1 raised to power 8. Now it's coefficient, please. Take a look at this one. I'm looking for the coefficients, but not the value itself. So what will I do in that manner? So whenever I see that, I will still come back to this n combination r, a raised to power n minus r with b raised to power r. So in that aspect, our arrow is unknown. We just have to find it. So what do? We'll have 8 combination r. I will have, this is my a, and this is my my b. So I will have 2x raised to power 8 minus r. Then I will have minus 1 raised to power r. Now, what do? I select those with x. So I will have 8 combination r. I will have 2 raised to power 8 minus r. That's for this one. I will have x raised to power 8 minus r. They share common power. Then I will have minus 1 raised to power r. Now, this is the only one that has what? X here. So carry this, equate to this. I'll have x raised to the power what? 8 minus r is equals to what? X raised to the power what? 5. This will cancel this. I have 8 minus r is equals to what? 5. So I have minus r is equals to 5 minus what? 8. So our answer is r is equals to this. Then both are minus 1, both are minus 1. This cancel, this cancel. So r is equals to what? 3. So the coefficients I'm looking for are just these people without the x. That's, I have to substitute the coefficient of the what? X with that is going to be what? 8 combination r, put this here. I will have 2 raised to the power what? 8 minus r. And the last one is what? 1 raised to the power what? R. So when you put the arrow there, which is what? 3. I have 8 combination 3. I have 2 raised to the power what? 8 minus 3. I have minus 1 raised to the power what? 3. So from that aspect, if I'm to complete that, I will have a picture that should be depicted in this manner. Then I'm going to have 8 factorial over what? 8 minus what? 3 factorial with what? 3 factorial. That is for this part. Times what? 2 raised to the power what? I have 5. Then minus 1 raised to the power 3 is what? The same minus 1. So I have 8 factorial over what? 5 factorial times what? 3 factorial times 2 raised to the power 5 minus 1 here. So from that point again, I will have something that appears to be in this manner. 8 times what? 7 times what? 6 times 5 factorial divided by what? 5 factorial times 3 times 2 times 1. Then what is here is what? 2 raised to the power 5 against minus 1. So this will cancel this. Then from that point again, this will cancel this. So I have this times this, which is what? 8 by what? 7 times what? 2 raised to the power, which is what? 32 times minus 1. So when I punch that, I think I will have a value in this manner. So we will have minus 1792 as our answer if we should punch that in the calculator. And let's take a look at an example. Let us let's expand 0.98 raised to the power 4 using binomial expansion. Now, when you see a question like this, it's your duty to actually, you have to, like I said, binomial is a pair of a number combined by either plus or minus. So I need to make this to be in the same manner. Now I have 0.98, and I think if I associate 1 minus what? 0.02, I think that will give me 0.98. So if that is the answer, like when I subtract 0.02 from 1, and I get that, I think perhaps I can manage it to be in this manner. So instead of having it this way, I will have it to be in this fashion. Now, when I have it that way, then bear in mind automatically that this part is my A, and this part is my what? B. But I still have negative. So if I'm to expand that, let's say I have, since it's to power 4, I'm to expand that, I have n combination what? 0. A raised to the power what? N minus what? 0 with what? B raised to the power what? 0 plus what? N combination what? 1. I have A raised to the power what? N minus 1 with what? B raised to the power 1 plus what? N combination what? 2. I have A raised to the power N minus 2 B raised to the power 2 is the fourth term. That's 1, 2, 3. Then the last one, which is what? N combination what? 3. A raised to the power what? N minus 3 what? B raised to the power what? 3. That should do it. So all I have to do is to substitute these values into this, then I'm done. Then if that is true, but remember, the signs has to be alternative. So if here is plus, automatically here should be negative, and here is plus, here should be what? Negative. So to compensate for that. So what will I do now? I'll substitute them. So my n is 4. I have 4 combination 0 there. A is what? Power 1. Then I have 4 minus what? 0. B raised to power what? 0. That's what? I have 0.02 raised to power what? 0. Then I move to what? Minus. I have 4. Combination what? 1. A, which is the 1, raised to power what? 4 minus 1 is what? 3. Then I have what? 0.02 raised to power what? 3. Then I have plus 4. Combination what? 2. A, which is 1, raised to power what? 4 minus 2, which is what? 2. I have 0.02 raised to power what? 2. Plus, okay, minus, sorry. I have 4 combination 3 then I have a to be what? 1. Then I have 1 minus what? 1 minus what? That, which is, I will have, then I will have, that's 4 combination 3, that will be power 1, b raised to power 3, which is what? 0.02 raised to power 3. So the last term which I did not write is going to be what? 4 combination what? 4. I have 1 raised to power what? I have 4 minus what? 4, b, which is 0.02 raised to power what? 4. Now note something. If you have power 4 and you're asked to expand it, you're expecting the number of times to be what? 5 when you expand it. If it's power 6, when you expand, the number of times will be what? 7. So that's always a trick. So when you're taking your calculator and not point this thing, or you can just leave this because the question demands you should just expand it. So that is how to what? Expand it. Although some cases you may have to add. So it's not a must that you put subtraction. So if you look at it as okay, I subtract or add, basically it's 1 or 2 that you can do that. That's the way to do it. So thank you for watching. If you have any question, please forward them to me. Yeah.